All right, starting our new part of chapter 3. This is kind of connected to what you've talked about in 8th grade last year, or 7th advanced if you call it that. Something, if you remember, called scatter plots. Scatter plots are just, it looks like random dots on a graph, literally scattered everywhere. But what you did last year in 8th grade was you just learned how to name them and make predictions using them. So you remember them as the direction of the dots. If you see dots in going upwards, this is called a positive association. You also learned this as when X increases, Y increases. And then if you have the dots going downward, like a negative slope, this is called negative association, which is when X increases, Y decreases. And then you have the third type, which is called no association, which literally means like there's no direction whatsoever. There's no up, there's no down. The dots just look completely random. And we don't see that one as often as 8th grade does, but it's good review. Where algebra is different is we take it one step further and we find what's called line of best fit. This is determining a line that could go through the dots as best as possible. Obviously, if we drew a line through the dots, it wouldn't connect with every dot. Otherwise, it would look like connect the dots, which we don't do. We just draw a line of best fit, which means a linear line that fits through the dots as close to the middle as possible. Through the middle of them. Same thing on this one, like a line that goes through the dots, as many of them as possible, but keeping it even on both the top and the bottom of the line. And there wouldn't be a line of best fit in no association just because of the how random the dots are. Now, how we find that line of best fit is we're going to use the TIs, and I'm going to show you what it looks like on Desmos. And again, it just comes down to what do you have access to. To find that, we figure out how strong of a line we can make with these dots, something called correlation coefficient. This number just determines how close together are these dots to making a straight line. And we have a scale from -1 to +1 and 0 in the center. So if it's any sort of negative correlation, then we have a negative correlation coefficient. If it's on the negative side but close to 0, we call it a weak negative. If it's on the negative side but close to -1, we call it a strong negative. And we'll practice this here in a second. And then we have on the positive side, if it's close to 0 on the positive side, it's a weak positive. This means it looks like it's going a positive direction, but the dots are not really close to a straight line. We'll talk about that in a second. And then if it's a positive on the positive side, but closer to +1, then it's a strong positive. And again, we'll talk about it. Now, how we do this in the TIs is we use stat, but we have to turn on our diagnostic. To go to our diagnostic in the TI84s, which is handy to know both, is we go to mode, which is next to second. And if you scroll down enough, you see in blue stat diagnostic, how it's turned off. Well, what we're going to do is we're going to turn it on, if you can see that. Okay, so it's flashing on, so mode, scroll down to stat diagnostic, and then I'm going to turn it on by hitting enter, and that's it. So all you do is hit clear. Now, if you reset your calculator, like if you do 2nd + 7 1 2, then you have to turn on the stat diagnostic over and over again. So that's the only kicker about using TI84s. And then so let me show you an example here. If I look at number 1, so what you would do like any table is we would type this into stat. Now this isn't like in chapter 3 part 1 where you just type in the first 2. On a correlation coefficient, you have to type in every single value in for X. So, sorry, let me zoom out there a little bit. If I look at my example on number 1 for my notes, I have 0, 10, 20, 30, 40, 50, 60, 70, and 80. And then on my Y's, 79.2, 80.1, 77.5, 68.7, 57.4. So kind of like what we did with slope and y-intercept, nothing different there. Okay, and then what we're going to do is do stat calc 4 like we've always done. And what we're asking the calculator to do is find that linear equation that best fits these dots, as random as they may be. Because if I graphed these, then these dots would look similar to this or this, where it would not be a perfectly straight line. They'd be random and look like a scatter plot. So we hit enter. Now, you notice the difference is I have more than A and B. I have more than the slope and the y-intercept. We have what's called the correlation coefficient. Now, the only one I look at is the R value because we're talking about linear, not quadratic. So we're doing R, and notice that that's a decimal, negative 0.97. We'll talk about that in a second. If we found our line of best fit, this is your y equals mx plus b, it would be y equals negative 1.06, I round to the hundredths place, plus 92.31. Now, the reason why you get such random decimals is because this calculator is trying to find as close to a straight line as possible going through these random dots. And obviously, I would get whole, nice, pretty numbers if it were a perfectly straight line. But since they're not, it's finding the closest it can, which is why you end up with a decimal like this. Now, the next part is, of course, the correlation coefficient. This is that strength, like how close to a straight line do those dots make? Well, if you notice it's negative, that means it has a negative slope. There it is. But how close to they are is how strong that negative is. Since it's negative 0.97, that's really close to negative 1, which makes it a strong negative. And that's literally its name, a strong negative. There are questions on the EOC that literally ask how it would rank. Would it be a strong negative, weak positive, or strong positive? And there it is, strong negative. Now, the last type is making a prediction using this equation. So it says estimate the average temperature for a city with a latitude of 25 degrees. That means I'm going to plug, if latitude is X here, I'm going to plug in X for that. So how we've done it in the past is we're going to use 25 stow X, like we did with evaluating functions, and then I'm going to type in negative 1.06 X plus 92.31, and it gives me an estimation of 65.81 degrees Fahrenheit because that would be my prediction. Again, I know it's a lot to cover, but that's how you would use TI84. So if that didn't make sense, make sure you go back and watch the video again. What I want to show you is how I could use this for or let's do another one using TI84, okay? So the trickiest ones are the tables that have years, because you do not type in 1,980. That's not a numerical value. Since it's a year, and since this is talking about 1980 being the first year, we're going to put 0 for 1980, and then we have to figure out how many years between each value. So from 1980 to 1984 is 4 years, so 0 to 4. From 1980 to 1988, that's 8. From 1980 to 1992, that's 12. From 1980 to 1994, that's 14. From 1980 to 1998, that is 18 years. So instead of using years, we have to convert those to numerical values, single values, so 0, 4, 8, 12. So that's what I'm going to type into stat. Now, here's the kicker. If I use TI84s and I do second plus 712, nothing wrong with that. But I have to turn my diagnostic back on, which means I'm going to go to mode, and notice on stat diagnostic, it turned back off. Every time I reset my calculator, it turns it off. So I'm going to go turn it back on, and now I can type this into stat. 0, 4, 8, 12, 14, and 18. And then I go on the right and type in those Y values. And then, make sure to type it in correctly. And then I'm going to do stat calc 4, enter, enter, enter. So again, you're going to get crazy looking decimals because when I plot these points, they would be the most random looking dots on a graph. So we're going to round to the hundredths place, which is y equals negative 2.29x plus 430.56. And you don't want to round to the whole number because then your answer would not be that accurate. So I always go to the hundredths place. Heck, even going to the thousands place would be okay too because it's more accurate. But always go to the hundredths for accuracy. Never round to the whole or to the tenths. And again, what I'm looking at is the correlation coefficient, which is the R, not the R squared. So it's negative 0.81. And on my scale, that would be a negative close to -1, which would be a strong negative. If it was anything on the negative side closer to 0, that would be considered a weak negative. So that's the difference between there. Now I look at my prediction of a 2012 Olympics. So that means I'm going to figure out how many years 2012 is from 1980. From 1980 to 2012, that would be 20, 30, 32 years. So I'm going to do 32 stow x, and then I'm going to type in my equation that I wrote. Negative 2.29x plus 430.56, and then I get a numerical value of 357.28, and that's my answer. Okay, so that's using TI84s. Now we're going to talk about how and why Desmos is beneficial for this and a little bit quicker and easier. Of course, if you have access to it, TI84s is great. It's on your handheld. You don't have to worry about going to an internet base, but let's talk about the difference. So if I look at number 3 on my notes, notice it still has years. So I do still have to convert that. So 1980, give me 1 second. Let me go down. 1980 needs to be 0, and then I look at the years after it. So 1980 to 1985 is 5, 1980 to 1990 is 10, 1980 to 1994 is 14, 1980 to 1995 is 15, 1980 to 1996 is 16, 1980 to 1997 is 17, and 1980 to 1998 is 18. So be prepared to make sure you're watching your scale, because it's not always going to be the same pattern. Now I'm going to type that into stat, but instead of stat, I'm going to do Desmos. Now we know how to type this into this Desmos already. You add a table, you hit the plus sign and hit table, and you're just going to type all the values in. So I've got 0, 5, 10, 14, 15, 16, 17, and 18. And again, just like before, you do have to type in each value, not just that. On my Y's, I'm going to type in 86, 126, 166, 217, 231, 245, 261, 279. Okay, now here's the beauty of Desmos, is you don't have much to do. What you do is you click this icon, and that literally means line of best fit. So I click on that. Now, next semester, we'll learn different ones other than linear regression. We don't learn all of these, obviously, but it automatically defaults to linear regression. And the beauty of Desmos is that's my equation right there. Now, also, it finds the correlation coefficient for me. The kicker is you have to remember to look at R, not R squared. So if you look at R, it would be 0.99. Not much of a difference, but it's still, you have to look at R. So it's 0.99. So my equation, if I look at my notes, would be y equals 10.60x, and my y-intercept would be plus 75.448 if I rounded. Now, what nice part about Desmos is I can go ahead and use that decimal. I don't have to round, and it would give me an even more accurate answer. And then my correlation coefficient, the R, again, would be 0.99, which if I look at my scale, is this time it's on the positive side, and it's closer to +1. So that makes it a strong positive instead of a negative. If it was somewhere on the positive side but closer to 0, then it would be a weak positive. So you got to know how to use this scale. Now, here's the nice part about Desmos also, is I can click this little icon right here where it says an arrow with a little notepad looking thing, and it automatically drops down my equation to where I don't have to type it in. And normally what we would do is stow x for my TIs. Here, if I need 2008, well, 1980 to 2008 would be 28 years. I'm going to put 28 where x is, which means I'm going to do parentheses 28 like that. Replace x, but you have to put it in parentheses. And look what this does. It gives me 372.32, so on. And that is my answer. So Desmos a little bit quicker, okay? Let's do the same thing for the next one. So what you need to do is reset, which means you can just hit the X if you want, or settings, delete all is how you clear it. I'm going to show you a different kind of question though. So if we look at our notes, this time if I have a graph, I have to go find the points myself. So this one would be 0, 16.5. This one would be 117. This one would be 2, 17.5. This one would be 3, 19. This one would be 4, 20, and this one would be 520.5. Okay, so we're gonna type that into Desmos again. Again, to do Desmos, you just hit plus sign and hit table. And then I just type in my values. So I'm gonna do all of my X's. I've got 0, 1, oh, not 10, 2, 3, 4. Oh, 4 was an option. 3 and 5. Nope, 4 was. My goodness, sorry. Okay, and make sure if you have any extra values to delete that. All right, then I have my Y's, which would be 16.5. Oh my goodness, struggling today. 16.5, 17, 17.5, 19, 20, and 20.5. And again, all you do is click. Oh, actually, I want to point out something over here. As I'm typing those in, what my calculator does is graphs it for me. So you can see the dots, how random they are. That's what makes it a scatter plot. And then over here, I'm going to click this icon with the line through it, and it even draws the line of best fit for me, which is kind of cool too. But what I want to focus on is the equation itself. So right here, it gives me my equation. So if I round to the hundredths place, it would be y equals 0.87x plus 16.24. My correlation coefficient, again, that's the R value, the second one, the lowercase one. So that'll be 0.98, which on my scale would represent a strong positive because it's closer to the positive one on the strong side. So strong positive. And then to figure out what 2005 would be, the starting year was 1990. So from 1990 to 2005, that would be 15 years. So I click this little icon here, and I'm going to replace X with 15 by using parentheses. And then it gives me what 15 years would look like. So it would be how many books, or how much did they spend on books then? It would be about $29.31. And that is the difference between TI and Desmos.